This is for Year 11 methods, exercise 3L question 5 and exercise 3D question 3. In this situation, we've got a piece of wire which is 80 centimeters long and it's cut into two pieces. One piece is to be bent into a square and the other into a rectangle with to a rectangle 4 times as long as it is wide. So it says let x be a centimeter on the side of a square. So if I draw a square, it's not a very good square, but if I draw a square and I draw a rectangle, I know that the side length would be x's. For the rectangle, we let the width equal y, and we know that it is 4 times as long as it's wide, so 4y. 4y and y there. So part A asks us to write a formula connecting y of x. Now we know the perimeter, that's 80, because that's the length of the wire. So the perimeter 80 has to equal the perimeter of our x's and y's. So the perimeter of the square is 4x, the perimeter of y, of the rectangle is 10y, because if you add the y's together you get 10y's. If I simplify that expression, I divide both sides by 2, I get this. Now I can put y in terms of x's, so I can make the y subject. 2x equals 5y, so y therefore equals 40 minus 2x on 5. And we've got an expression where we have y in terms of x, which is what we want. I think in the book that is an acceptable answer as well. But we'll need this for the next part of the question. Next part is let area be the sum of the areas of the square and rectangle. So area equals the sum of the square, which is x squared, and the rectangle. You just times length by width, so 4y squared. Now we're not quite done there. It says in terms of x. We've got a y here, so I won't get rid of it. We get rid of it by subbing in y in terms of x, because that's what we did in the first part. So we go 40 minus 2x on 5. And we've got an expression of the area in terms of x only, which is what the question asks. However, it's always good to simplify our expression, so I can enter this on a calculator, and so I enter this on my calculator. I'll just copy that expression. So I entered it on my calculator. What I did was I went interactive, transformation, expand, okay, and we are left with that expression. Now, so I can write this answer, 41x squared on 25 minus 128 x on 5 plus 256 as my final answer to the area in terms of x. Now, the next part says find the length of both pieces of wire if a is to be a minimum. Okay, so we've got a correct expression. We notice that this is a positive correct because the coefficient of the x squared term is positive, so we'll know it will look like that, or something like that. So what I'm going to do is I'm going to attempt to graph this. So I'll press my graph window, I highlight what I want to graph, so that's the expression I want to graph, I drag down. Now, if you run into problems, a troubleshooting method to get the graph window right is to press Zoom Auto, because Zoom Auto generally gives you the point you want on the graph, because it knows where the minimum or maximum is. So to get the minimum for x, because this is a in terms of x, we go analysis, gsolve, min. and we've got the minimum as 7.80. So 7.80 is where the minimum area occurs. Okay, so x equals 7.80. Now, we have to relate back to the question. Find the length of both pieces if A is to be a minimum. So, for A to be a minimum, we need to sub this in to what each original piece was. So, for the square, we know it's 4x. So, 4x equals 4 times 7.8, which equals, so I can do that on calculator, obviously. Decimal mode, 31.2 centimeters, I think. And we know that the length of the Y wire is 10y. So 10y equals 10 times 40 minus 2x. So x we know is 7.8 divided by 5. So let's just work that out on the calculator. So I've got 40 minus 2 times 7.8 equals divided by 5 times 10. 48.8. So there you have it. That's how you do exercise 3R question 5.